Today we will calculate the value of Venturi head for Venturimeter. Yeah. First of all, draw the figure of Venturimeter. Here, this is pipe. This is converging portion of Venturimeter. This is throat and this is diverging portion. You know that. And the length of diverging portion is long than the length of converging portion. You know that. And the dia of throat is generally kept the half the dia of the pipe. Yeah. Now, a U-tube manometer is fitted at 101 and 22 section. Yeah. When there is no flow through the pipe, the deflection of mercury in the manometer is at the same level. But when liquid is flowing through the pipe, then there is a deflection Y in the manometer. Yeah. Now, consider this is M point and at the same level this is N point. Yeah. We know that at the same height there is no pressure difference. So, pressure at point M equal to pressure at point N. Or applying Bernoulli's equation at 1, and 2 section. Yeah. The total head at point M, this is first of all, say this is potential head Z. This is potential head Z. Yeah. So at 1 section, potential head Z plus pressure head, this is P1 by omega, and here there is no velocity, so kinetic head is 0, and that is equal to total head at N. At N point, the head at this portion, this is Z and this is Y. So this is Z minus Y. Yeah, this is Z minus Y plus this deflection Y. So here the head is Y, where A is equal to specific gravity of liquid in the manometer with respect to the liquid flowing through the Venturimeter. That means if this is mercury in the manometer and here this is oil, so here A is equal to specific gravity of liquid in the manometer, that means specific gravity of mercury, and here specific gravity of oil, this is SO. Yeah. Plus pressure head at 2 section, this is P2 by omega. Yeah. So here P1 by omega minus P2 by omega, we know that the difference between pressure head at 1 and 2 section, this is called Venturi head. So this is equal to here Z and Z, and here if you common S Y, so this is S minus 1, and this is actually Venturi head. So for horizontal Venturimeter, Venturi head H equal to P1 by omega minus P2 by omega, or Y into S minus 1. Yeah, you remember. Now we calculate Venturi head for inclined Venturimeter. Yeah. Inclined Venturimeter, say this is center line, this is pipe, This is converging portion, this is throat, and this is diverging portion. This is pipe. This is pipe. Yeah. This is two section, and here this is one section. Now a U-tube manometer is fitted between 1 and 2 section. Yeah, at 1 and 2 section. Okay, and this is deflection Y for mercury manometer. Yeah, and here area A1, velocity V1, and at throat this is area A2 and velocity V2. This is potential head Z1 at 1 section, and here this is Z2 potential head at 2 section, and consider this point M and at the same level this point N. Yeah, and at the converging portion, beginning of the converging portion, this is point A, and at the throat this is point B. And consider the Venturimeter is inclined at angle theta. Yeah. Now at point M and at point N there is no pressure difference. That means pressure at point M, this is equal to pressure at point N. Now at 1 section Z1, this is potential head, plus at 1 section pressure head, this is P1 by omega, equal to at 2 section, that means at end point, yeah, potential head, this is Z2, this is Y, so this is Z2 minus Y, plus for Y deflection, here the pressure head, this is SY. In the same manner, AS equal to specific gravity of liquid in the manometer with respect to the specific gravity of liquid flowing through the pipe or Venturimeter. Yeah, that means here AS equal to specific gravity of mercury in the manometer by specific gravity of oil flowing through the Venturimeter, if oil is flowing through this pipe. Yeah, and if water is flowing through the pipe, so S equal to, actually this is SM, as there is no specific gravity of water, that means 1. Yeah. Now last at point 2, that means at end point, pressure head, this is P2 by omega. Yeah, so we know that Venturi head AH, that is equal to S into Y minus 1, Y into S minus 1 for horizontal Venturimeter, Y into S minus Venturimeter. So here we consider here Y into S minus 1. Look at the figure. Y into S minus Y common S minus 1. This is equal to here P1 by omega minus P2 by omega, yeah, plus here Z1 and Z2, this is Z2. Yeah, that means here Venturi head H equal to Y into S minus 1, that is equal to the pressure head difference between 1 and 2 section plus Venturi head difference between 1 and 2 section. Yeah, this is actually Venturi head for incline Venturimeter. And you also notice here, if you draw a horizontal line from A point and a vertical line from B point, and this intersection point if you consider C, that means here ABC, this is a right angle triangle. ABC, this is a right angle triangle, and here angle theta, show opposite side BC, this is normal, AC this is base, and AB this is hypotenuse. Okay, now if we consider sin theta, it will be the base here. Yeah, not tan theta, this is sin theta. So this is normal and this is hypotenuse AB. Yeah, so AB, look at BC by normal by hypotenuse. So this is BC equal to AB sin theta. Yeah, and look at the board. This BC, that means Z2 minus Z1. Yeah, that means here we can write Z2 minus Z1 by AB. Yeah, and so here Z2 minus Z1, this is AB sin theta. Yeah, but here Z1 minus Z2, here Z1 minus Z2, so this is minus AB sin theta. That means this equation can be rewrite in this form. Here H equal to Y into S minus 1, or this is P1 by omega minus P2 by omega, that means pressure head difference between 1 and 2 section, plus here Z1 minus Z2, that means minus AB sin theta. So here this is minus AB sin theta. It can also be written in this form. So Venturi head for inclined Venturimeter, there is two equation, H equal to Y into S minus 1, that is equal to P1 by omega minus P2 by omega plus Z1 minus Z2, or in this form. Yeah, and on the next day we solve different numerical problems based on this equation.